The island of Madeira is located in the middle of the Atlantic Ocean, about 540 kilometres off the coast of Africa. Its volcanic origin and dense and varied vegetation gives it an exotic and wild nature that attracts thousands of tourists each year. Today, Madeira is home to a new kind of wonder, a communications centre where satellite antennas grow side by side with exotic trees. Here, Paris-based satellite operator Eutelsat gave its Madeira subsidiary the mission of building a high-tech facility for the monitoring and control of its satellites, a task that Eutelsat Madeira undertook with enthusiasm and competence. It led to what is today the TCR, or Telemetry Command and Ranging Centre of Canissal. From the initial blueprint to the final building and the installation of equipment, the project required extreme precision. The need for a particular attention to detail, together with a very tight time schedule, were challenges that Eutelsat Madeira met, thanks to perfect teamwork.
A project like this, no satellite operator has in-house competence to run it from A to Z. Of course, Eutelsat experts have issued, let's say, the basic specification, and then we contracted specialized companies for the civil works, the ancillary facilities, the telecommunication equipment, the antennas, the transmit and receive equipment, RF equipment, amplifiers, receivers.
In order to bring together such a team of experts, Eutelsat contacted one of the leaders of the satellite industry.
The first phase of the project was to support Eutelsat to do the selection between different sites. There was mainly two sites, one at the top of the mountain, the other one based in Canissal, close to the port area. And during this phase, it was to establish the best compromise between different characteristics such as accessibility, security, or also the visibility to the geostationary arc. The second phase was to recruit an architect to prepare the project. The third phase was to recruit the building companies for starting the construction of the site, and also recruiting a project pilot to control on a daily basis these building companies to be sure that everything was done correctly.
There were involved 12 specialities in this, 12 specialists in this project concerning technical parts of the building. And the thing which was mostly interesting was get these people work together and get everything ready in such a period of time. So that was the main challenge.
Nós somos a empresa que executa a instalação para o Eutelsat.
We're the company that constructed the building for Eutelsat.
Portanto, começar desde o início a trabalhar no planeamento.
It was important for us to work on the plan from the beginning in a very accurate way.
Não era só a Edifer Madeira que ia intervir no espaço e que ia fazer a construção. Há outras empresas.
The plan did not involve only Edifer Madeira to carry out the work and share the working area, but many other companies, some of them foreigners, such as the French company that installed the antennas.
Aquelas coordenadas, aquilo depois tem que encaixar tudo, aquilo em termos de planeamento, nós quando fazíamos, depois as outras pessoas têm que...
Everything had to be well coordinated in order to keep to the time schedule.
Para que eles possam desenvolver a sua atividade, tem que estar terminada nessas datas acordadas.
Timing was a key issue for Eutelsat.
Fundamental para o Eutelsat.
This operational and financial effort is aimed at strengthening the control network of Eutelsat satellites, one of the leading satellite operators worldwide. The geographical location of Madeira has been a major element in favour of building this project on the island. Following a decision of the group's shareholders, Eutelsat Madeira was incorporated in June 2008 with two ambitious goals in mind: taking advantage of the strategic position for the control of Eutelsat satellites and improving the group's commercial penetration in targeted, fast-growing markets such as Africa and South America.
The main advantage of the island of Madeira is, of course, its longitude that allows us to expand towards west our capability of controlling satellites. A commercial component that consists on providing satellite telecommunication services by the ownership of a part of the W2A satellite, which became operational at the 10 degrees east orbital position of Eutelsat.
And in order to achieve its commercial objectives, Eutelsat Madeira will count on the W2A satellite, located at 10 degrees east.
10 degrees east is one of the main and first orbital slots of Eutelsat, and W2A was launched to reinforce and expand the capabilities of Eutelsat at that slot.
The fast-growing communication needs between multinational companies in Europe, Brazil, Africa and the Middle East is an attractive marketing opportunity for implementing Eutelsat Madeira's strategy. Eutelsat Madeira will rely on 10 C-band and 15 Ku-band transponders of the W2A satellite to achieve its commercial objective. While the successful launch of the W2A satellite was essential for the accomplishment of the company's commercial objectives, an ambitious technical challenge pushed the team working at the Eutelsat Madeira project into finding the most appropriate location to host the satellite control centre.
We conducted a survey of the island in order to identify a good place to host the center. We finally decided to build the center in the free trade zone of Canissal. The constraints for an infrastructure like this are open visibility to our orbital arc where Eutelsat satellites are positioned, clearance from that point of view, clearance also in terms of radioelectric interferences and coordination with existing radioelectric environment. Another important element relates to the specificity of the weather in Madeira is the wind, strong winds that happen from time to time, but nothing that prevents the normal and good operation of the facilities.
The free trade zone of Canissal, located in the eastern part of Madeira, met all the main requirements. In particular, it had good open visibility to the geostationary arc, broadband data connectivity, and the basic infrastructure already in place. By September 2009, the management team of Eutelsat Madeira was ready to focus on the blueprints.
The surrounding area, it's an industrial part of the island, and the buildings are big, and most of them are industrial pavilions. So this is a small building. How do you put a small building in the middle of the other ones? It's basically a box, and we have to two floors, upper floor offices, and downstairs on the ground floor we have mostly the technical and control rooms. Our main concern was how to put a small building in a park with huge and a great quantity of satellite antennas. It will be like a house in a garden.
While the architects are fine-tuning the final details of the project, 7,000 kilometers to the west, in Texas, one of the leading satellite antenna manufacturers is packing a container bound for Canasal. October 2009. The soil of the future Eutelsat TCR is subjected to a series of tests with specialised equipment. The volcanic origin of the island requires that an accurate geological survey is conducted prior to construction to ensure that the foundations provide the required high level of stability to the building and in particular to the antennas.
We have a site that has been dimensioned for 12 antennas. We had to make sure that the soil was appropriate to build not only the building, but most importantly, the antennas.
The soil in this area of the island is composed of what we call the final stage of the volcanoes, which is very thin layers of dust. The fact that Madeira has got volcanic origin and the fact that the surface changes so quickly makes it very unpredictable. Meaning, you are in Canasal, the place where we are, and the main building is made with normal foundations 1 meter below the surface. The further west antenna, you can only find the good soil for the foundation 15 meters below.
But how is it possible to ensure the necessary stability of the site using cost-efficient technology?
Micropile is a very recent technology that we use in order to transmit the weight of the building into deep layers of soil where the mechanic behavior of the soil is more according to what we want. By using a kind of pile made of very high strength steel, you can transmit all the efforts into the deep layers. The layers of soil that stand the whole building are underneath 20 or 30 meters underneath, so you don't have to spend money doing huge foundations. You just put a small macropile which no one sees, and you can build very effective foundations for very heavy efforts on such conditions.
November 2009. After weeks of careful analysis of the soil by the civil engineers, it was clear that the building and the antenna foundations needed the micropile technology in order to guarantee the necessary stability. The construction company lays down the pickets and defines the perimeter of the building and the antennas. Tens of micropiles will be slipped into the ground before construction takes place. After travelling for weeks on the open sea, in December 2009, the cargo ship enters the industrial port of Canasal with its precious container of satellite dishes and sophisticated telecommunications equipment. Meanwhile, the construction of the TCR Centre is running at full speed. It's here that the Portuguese technicians working at the centre will ensure 24 hours a day the proper functioning of satellites which are navigating away in space, 36,000 kilometres above our heads. And in preparation for this mission, they're sent to France for an intensive training programme that will bring them up to speed with the latest technology. January 2010. 70 kilometres west of Paris, Rambouillet Eutelsat Teleport and TCR Centre, a jungle of oddly shaped satellite dishes. So how big is Eutelsat, this European telecommunications giant? Today, Eutelsat is a multicultural workforce of 661 professionals from 28 countries. 26 satellites located at 22 positions of the geostationary arc, between 15 degrees west and 75 degrees east, covering 150 countries in Europe, Africa, Asia and the Americas. A full range of consumer and professional video, data and broadband services. Broadcasting over 3,600 television channels and 1,100 radio stations. An audience of nearly 190 million cable and satellite TV homes. Consolidated revenue to the 30th of June 2010, above €1 billion. There they are, the 4 Portuguese technicians who will soon be in charge of controlling the correct geostationary position and monitoring the performance of Eutelsat satellites. This is the renowned control room of the TCR Centre of Rambouillet. For security reasons, access into the heart of the centre is restricted to authorised staff only. During their 12-week training programme, they share knowledge and experience with their colleagues in a control centre located near Paris, similar to the one they'll be in charge of. February 2010. The platforms for the first 4 antennas are ready. Determining their terrestrial coordinates and positions is the result of a very meticulous process. The margin for error is minimal. The flow of information travelling from the satellites to the antennas has to be continuous. An electrical breakdown at the TCR Centre would abruptly end any communication. It was therefore paramount to provide the Eutelsat Madeira site with a specific, uninterruptible electrical power supply system.
We have to make sure that power supply is absolutely redundant, so we have diesel generators backed up by a battery bank in a typical power supply configuration.
Uma série de redundâncias que foram criadas.
A series of special measures were taken at the site, which are unusual for a normal building, both on the cooling and the electrical system.
Normalmente não tem aquele grau de redundância.
There always has to be an alternative electrical source to supply the TCR
Falha
centre.
em qualquer instalação.
Having crossed the Atlantic, the containers arrive at the site and complete the last leg of their journey. Unpacking the antennas, classifying the parts, and completing the puzzle is a task handled by another expert team. The assembly of the 100 pieces that make up an antenna follows a specific pattern.
There is a field engineers and technicians on site doing the installation, and there is a back office people here with expertise level and in connection also with the equipment vendors. With daily reports, we can face any trouble on the field by bringing support solutions in real time and to respect the planning, because in most of the SATCOM projects, timing is always a strong requirement.
Following detailed procedures and based on previous experience, they'll extend the antennas from nothing to an approximately 5-metre high structure in just a few hours. 3.8 clover-shaped dual offset, all aluminium reflector antennas are fully steerable and are capable of accurately pointing and tracking the Eutelsat satellites. March 2010. As the building begins to take shape according to the 3D drawings, the Eutelsat Madeira site looks more and more stylish each day. It's time to start installing the core of the TCR centre. The control room is unveiled. The 4 technicians are back from Paris and start making acquaintance with the facilities and the technical equipment. End of April 2010. The satellite dishes and the various subsystems are finally installed and tested. It's a critical moment, a moment when months of hard work from different teams depends on a sinusoid peak showing that the antennas do track the satellites. And the result is positive. October 2010. Less than 12 months from the initial soil testing and construction kickoff, the Eutelsat Madeira TCR Centre is a beautiful reality and is ready to ensure the monitoring and control of communication satellites. Now the Eutelsat satellites have a new partner on Earth.
Nesta obra em particular, houve realmente espírito de equipa.
In this particular project, there was a special feeling with the team. Eutelsat, Edifer, the project manager, everybody worked in order to keep the standard of quality at the top level within a time frame agreed with Eutelsat.
Está à vista, no tempo ou no prazo, ter as decisões no prazo compatíveis com o prazo de execução da empreitada.
What was interesting in terms of relationships within the team was the fact that there was not the typical contractor-builder relationship. When there was a problem, we all sat round a table and we found a quick and effective way to solve it.
Rapidamente como é que resolvemos, garantindo os padrões de qualidade e os padrões de desempenho que a instalação tinha que ter.
This team worked really, really well, and that's how we ensured the highest quality standards within the time frame.
E só desta forma é que se conseguiu cumprir o prazo que estava previsto.
A project that ran like clockwork, in which the construction of the Eutelsat facility on Madeira was achieved in just 1 year.
The implementation of the TCR Centre of Madeira has been a very exciting team project, putting together the competence of a large variety of experts, coming in first instance from our mother company Eutelsat, but also from the different contractors and suppliers. After the TCR Centre of Rambouillet in France, Madeira is the second TCR centre fully owned by the Eutelsat Group, that this way reinforces and expands the group capability to operate its own satellites. I'm very proud to say that the completion of this centre represents another important achievement of the Eutelsat Group in the world.
Teamwork that rewarded Madeira, giving this small and beautiful island in the middle of the Atlantic a top spot in the competitive satellite communication market.